Hello, once again, welcome back to Advanced Econometric class. In previous video, we discussed what is the difference between a single equation model and a simultaneous equation model, and what are the problems associated with the estimation of a simultaneous equation model, and what are the major problems that will be arised in applying OLS to these simultaneous into these equations embodied in a simultaneous equation system, and how this will violate the assumptions of OLS, mainly the covariance of xt and ut is equal to 0. Okay, then even if we apply OLS despite or ignoring these problem, what will be the uh, what will happen to our blow properties? Okay, yes. And also we discussed what are the endogenous variable, what are the predetermined variable, or how we can define the different variables appearing in a simultaneous equation model. Okay, yes. So today we are going to the next level, structure or behavior equations. Okay, so structure or behavior, both are same, structure or behavior equation. Okay, so in simultaneous equation model, in this simultaneous equation model, there are two different types of equation. First one is structural equation or behavioral equations. Okay, so the structural equation is basically describes what is the underlying structure of an economic theory or economy or the behavior of some economic agents. Okay, and this equation is basically derived from the theory. For example, suppose consumption is equal to Ct is equal to beta 0 plus beta 1 yt plus ut. This is basically a structural equation because it describes the structure of an economic theory called the consumption hypothesis or Keynesian consumption theory. Okay, and this Ct is equal to beta 0 plus beta 1 yt plus ut is directly derived from a theory. Okay, so whatever we have seen, or the equation that is derived from a theory is a structural equation. Okay, similarly, if you take quantity demanded, Qt is equal to beta 0 plus beta 0 minus beta 1 Pt plus Ut, this is also structural equation. Okay, and if you consider wages is a function of experience, W say is equal to beta 0 plus beta 1 Ex plus U, that's also a structural equation. Okay, yes, and the main feature of this structural equation is, if you have one structural equation, there will be one endogenous variable, or there is one structural equation for each endogenous variable of the system or in the system. Okay, so if you have two endogenous variable in your system, okay, then there will be two structural equation. Consumption is equal to beta 0 plus beta 1 yt plus ut, the first equations. In this equation, consumption Ct and yt are jointly determined, or it is called, one is called endogenous variable. But in next equation, yt is equal to Ct plus it plus gt, then in this equation also Ct and Yt are appearing. Okay, so we have two equations for each endogenous variable. For the first equation, the variable is C, endogenous variable is C. In the second equation, it is Y. Okay, so there will be equation for each equation. There will be structure. There will be one structural equation for each interdependent variable or each endogenous variable. Okay, so I'll take an example. Okay, so using this example, I will explain you. Okay, look at this example. Yes. Okay. Ct is equal to beta 0 plus beta 1 Yt. This is one structural equation derived from a theory. This is the second structural equation. Yt is equal to Ct plus It plus Gt. Okay. So here we have two structural equations. One equation for Ct and one equation for Yt. Okay, look at the second example. Wt, wage, is equal to alpha 0 alpha 1 un, that means unemployment, plus alpha 2 price level plus u1t. Look at these equations. This w is appearing here and here. Okay, this p is appearing here as the dependent variable, and here w is appearing here as independent variables. Okay, so wt and p are basically two mutually interdependent or interconnected variable. Okay, so we have one equation here, one equation here. Okay, then each equation, the dependent variable is either of our endogenous variables. Okay, so for each endogenous variable there will be one structural equation. Okay, so the structure equation is basically a equation that is derived from a theory. It will describe the structure of that theory. Okay, so if you are taking ISLM model will describe this. Yes, income consumption investment relation, or how interest rate are determines, or how income and interest rate are related. Okay, so it is basically describe the macroeconomic framework of an economy. If you take consumption function, it describes how the consumption and incomes are related. If you take investment function, it will tell you how investment and incomes or interest rate are related. If you take demand for money, it will describe how the demand for money and interest rate and incomes are related. Okay, so in each theory there will be, from each theory we can derive an equation. This equation will be the structural equation. Okay, so in structural equation, if you look at this, one more example, QDT, demand for quantity demanded for a commodity, is equal to alpha 0 minus alpha 1 PT plus alpha 2 income Y. Supply is equal to beta 0 plus beta 1 price plus beta 2 raw material price, or cost of raw material. Okay, so this equation describe the demand side of a market. Then this equation describe the supply side of the market. Okay, and we have equation for first model and second model, QQ. Okay, then if you take the money and income, money supply and GDP, here also we can see that for each endogenous variable there is one equation. This is what is called as structural equations. Okay, then in structural equation we can see parameters. Okay, this beta 0 beta 1, then alpha 0 alpha 1, beta 0 beta 1, alpha 0 beta 0, all these are called the structural parameters. Okay, and this will express the direct effect of each exponent variable on the dependent variables. Okay, how the changes in independent variable will influence the dependent variable that all these structural parameters will describe. Okay, yes. Now we have one more type of equations called reduced equation. Okay, so reduced equation is basically a reduced form of your structural equation. Okay, and this reduced form is basically an equation which is derived by solving the structural equation for endogenous variable. Solve for each endogenous variable, then you can derive a reduced form equations. Okay, and from this reduced form equation we can derive the reduced coefficients. Okay, so what we have to do here we have to solve this equation for each endogenous variable. What is meant by solve? Here, in an equations, mutually interdependent variable are called endogenous variables. Okay, so in each equation, there will be two endogenous variable. Okay, so instead of one variable, instead of variables that appearing as an independent variable, you take an endogenous variable that is appearing as an independent variable, you substitute this, you remove this variable and you substitute the second equation here. Okay, so what we are doing, substituting the second equation into first equation and first equation into second equations. So here we will derive two reduced form equations. Okay, I'll show you how to do that. Okay, now when we do such kind of a reduced form equation, okay, what will happen that the whole predetermined variable will come to the right hand side and endogenous variable will come to the left hand side. Okay, I'll show you how we can do that. After that we can discuss all these points. Okay, yes, now you look at these equations. Okay, so here we are having an equation Ct is equal to beta 0 beta 1 yt plus ut. Okay, then as you know that this yt is Ct plus it plus gt. So look at this Ct here and yt is also here. Ct, which is a dependent variable in the first equation, is coming as an explanatory variable in the second equation. Okay, then yt, which is a dependent variable in second equation, is coming as an independent variable in the first equation. This is what is called the joint determinants. Okay, yes. So what we have to do? Okay, so this equation alone is a structural equation 1. This is a structural equation 2. Okay, now what we are doing is yt. Okay, so here I am taking the second equation. Okay, yt, look at ct, yt is equal to ct. What is ct? Yes, ct is equal to beta 0 plus beta 1 yt plus ut. So what I am doing, I am substituting the value of ct in second equation. What is the value of ct? Beta 0 plus beta 1 yt plus ut. Okay, plus it gt, the remaining variable. This is it is remaining there, gt is remaining. Okay, here ct is there. Instead of ct I am substituting the equation of ct. Remaining items are it and gt, that I am writing it here and gt here. Okay, then I am not taking this gt because there is a bar there. Okay, so it means that it is constant. We are assuming that the government purchase is constant. Okay, so I am just removing that from my equations. Okay, so now the equation is yt is equal to beta 0 plus beta 1 yt plus ut plus it. Okay, Now you look at the equations. Yt is appearing here and yt is also appearing here. So there are, in an equation, a term or a variable yt is repeating twice. So what we can do? We can convert this 2yt into 1yt. Okay, so what I have, you just see what I'm doing. Okay, so what is the parameter of this yt? 1 into yt is yt. Okay, then what is the parameter of this yt? Beta 1. Okay, so I am bringing this term into front. So what will be the equation? Yt is equal to yt minus beta 1 yt. Yt minus beta 1 yt. Okay, so now I am just taking one yt. So what will be the parameter of this yt? 1 minus beta 1. Okay, so now my dependent variable is 1 minus beta 1 into yt is equal to beta 0 plus ut plus it. Okay, yes. Now I want to solve for yt. What I'll do? Okay, so all this, the parameter of this yt, that means 1 minus beta 1, will go to the right hand side as the denominator. Okay, so here beta 0 is there, beta 0 divided by 1 minus beta 1 plus I is there, investment is there. So what is the coefficient of investment? No coefficient is there, so it will be 1. Okay, so 1 divided by 1 minus beta 1 into it plus ut, that is 1 divided by 1 minus beta 1 into ut. Okay, now what I'm doing is, okay, beta 0 divided by 1 minus beta 1, I am taking it as a pi 0. Okay, then this second parameter I am taking as a beta 1. Okay, beta 1 into it. Then the third term I am taking as a I2 into ut. Okay, ut will be there, I2 into ut. Okay, yes. So now you look at the equation. What is the final equation? Yt is equal to pi 0 plus pi 1 it plus pi 2 ut. Okay, what was our original equation? This was our two original equations. Okay, now we have derived this equation. Now you look at this equation. Yt, in yt there were ct, but now there is no ct. Okay, and this yt is endogenous variables, and in right hand side it only is appearing other than uh, disturbance term. What does it mean? In your right hand side only the exogenous variable will appear, or predetermined variable will only appear in right hand side. Okay, so now in reduced form equations we can solve for each endogenous variables, or in structure we can solve endogenous variable in structural equations. Okay, and we can derive an equation called the reduced form equations. In reduced form equations there will be only one endogenous variables. Okay, and all the exogenous variable will come in the right hand side. Okay, so this is what is called reduced form equation. Okay, so I hope now you clear what is the difference between structural equation and the reduced form equations. Okay, now you look at, you might have learned in your first semester macroeconomics the ISLM model. Okay, so in ISLM model it is basically, this is the ISLM model. Yt is equal to ct plus it plus gt. Okay, where ct is equal to beta 0 plus beta 1 disposable income. Okay, and tax is alpha 0 plus alpha 1 yt. Tax depends on your income. Okay, consumption depends on your absolute disposable income. Tax depends on your actual income or current income. Investment depends on interest rate. Okay, and disposable income is nothing but your current income minus tax. Okay, and government purchase or government expenditure is equal to constant. Okay, so here also what we can do, we can see the equation Ct is equal to beta 0 beta 1. Then there's a equation, there's a variable called ydt, disposable income. What I'm doing, I am just substitute the equation of yt minus, or yes, yt minus tax, that is called disposable income. Now you look at the second equations. Okay, Ct is equal to beta 0 beta 1 yt. Okay, so there is a, instead of tax, instead of variable tax, I am just substituting the equation of this tax. Okay, so tax equation is alpha 0 plus alpha 1 yt. Okay, so alpha 0 plus alpha 1 yt. Okay, now yt is equal to ct plus it plus gt. Ct is equal to this equation, so yt is equal to, this is the ct, then this is the it, and this is the gt. Okay, so here also yt is appearing thrice. Yt, here is yt, one yt is here, one yt is here. So we have to solve for this yt. Okay, and when you solve for this yt, you will get this kind of an equations. Okay, so this term will be pi 0, this will be pi 1, this will be pi 2. Okay, so what we have done here, where here we had 1 2 3 4 5, there's a system of 5 equations. Okay, then we have solved for this yt. Okay, and we have arrived at a single equation. Now you look at these equations, yt, rt is exogenous. Okay, yes, so exogenous variable is coming into the right hand side. Okay, yes, now you look at the third equations, Keynesian income determination models. Okay, in this equation, this is basically mt is equal to money supply. Okay, total money. Yt is equal to gdp. Okay, and gdp is equal to money supply, investment, utility. Okay, this is a Keynesian income determination model. Okay, including money. Now what you do, I am solving for mt. Okay, so this is the mt equation. In mt you can see there is a y. Okay, so what I do, I am, instead of this y, I will substitute these equations. Okay, so mt is equal to alpha 0 alpha 1 yt. Instead of yt, I am just substituting the equation of yt. Beta 0 plus beta 1 mt plus beta 2 it, it plus u2t. Then remaining thing is u1t. This is u1t. Okay, now you multiply alpha 1 with all these terms. Okay, so alpha 0 will be the alpha 1 beta 0, alpha 1 beta 1 mt, alpha 1 beta 2 it, alpha 1 u2t, then u1t. Now you look at how many m's are there. One m is here, one m is here. Okay, so you bring this m into this side. Okay, so it will be 1 mt minus alpha 1 beta 1 mt. You take mt from there, then what will remain? 1 minus alpha 1 beta 1. Okay, so it will go to the right hand side and appear as a denominator of each variable and each parameters. Okay, so look at this. In here, this is the parameters. especially the intercepts. Okay, then alpha 0 plus alpha 1 beta 0 divided by 1 minus alpha 1 beta 1 plus alpha 1 beta 2 is here. This is the parameter. So alpha 1 beta 2 divided by 1 minus alpha 1 beta 1 into IT plus alpha 1 U2T divided by 1 minus alpha 1 beta 1 into U1T. Okay. So what I do is I will consider this as the intercept or pi 0. Okay. This as my slope coefficient pi 1. Okay, then it is exogenous. Okay, then this is basically the error term. So what I am doing is I am just giving a name W, pi 0 plus pi 1 t plus W. Okay, so this is the reduced form. Here we have solved for MT. Okay, now you can also solve for YT. How you can solve for YT? You take the equation YT, then here M is appearing. Okay, this is the M equations. So you substitute the value of M here. Okay, substituted the value here, beta 0 plus beta 1 into alpha 0, beta 1 into alpha 1 YT, beta 1 into U1T. All the other thing will be a reminder. Okay, now you look at how many y's are there here. One y is here, one y is here. Okay, parameter of this y 1, this is beta 1 alpha 1, so 1 minus beta 1 alpha 1 will go to the right hand side and appear as a denominator. Okay, so we will get this is the intercept, beta 0 plus beta 1 alpha 0 is intercept. Okay, divided by 1 minus beta 1 alpha 1 plus beta 2 1 minus beta 1 alpha 1 into IT. Then this is the error terms. Okay, here what I'm getting pi 2, the in our first equation we have given pi 0 and pi 1. Okay, now pi 2 plus pi 3 IT plus VT. Okay, now you look at this equation. In both equations MT and YT, the right hand side variable is exogenous variable called IT. Okay, so in reduced form equation only the exogenous variable will come the right hand side, whereas in structural equation both endogenous as well as exogenous variable or predetermined variable will appear in the right hand side. Okay, yes. So I hope you have understood what is the structural equation and what is reduced form equations and how we can find out structural equation, reduced form equation from the structural equations. Okay, yes. So that's all about today's sessions, and tomorrow on the next session we will discuss how to identify or what is the process of identification in simultaneous equation model. Okay. Okay, so I hope that you understood the things, and if you have not understood any concept or if you need any clarifications, then you can send me a message. Okay, thank you.